I'm in a dangerous situation. If the balance between this rope and gravity breaks, I plunge to my peril. Likewise, is there a force which balances the electron's attraction to the nucleus, preventing it from collapsing inwards? Bohr postulated that electrons exist in stable orbits and undergo uniform circular motion due to the attractive force acting towards the center of motion but perpendicular to the electron's velocity. Think of the nucleus as a celebrity, with paparazzi, electrons circling at a constant distance. However, Maxwell theorized that accelerating charges emit electromagnetic radiation, and thus Bohr's electrons should lose energy and spiral in towards the nucleus. Imagine that camera flash draining the paparazzi's energy, forcing them to move closer to the celebrity. Yet, this contradicts Bohr's stable orbits theory, portraying the limitations of classical physics. Instead, Heisenberg postulated that we cannot know both the location and momentum of an electron. Thus, even if we pinpoint the location of an electron, we can't predict where it will move, and thus cannot plot its path. Now, the paparazzi are moving through a thick fog that makes it impossible to identify both their position and momentum, blurring their motion into a probability cloud around the celebrity. We then graph the square of the wave function psi against position x to create a probability wave. Despite debates about psi's meaning, we know its square is proportional to the probability of finding the particle at x. By considering also distance from nucleus, we map a 3D probability density cloud. Thus, electrons can't collapse into the nucleus because they exist more as probability clouds surrounding it. However, these clouds reveal a small probability of electrons being localized within the nucleus. Upon this localization, a proton decays into a neutron while emitting a neutrino. If this were more common, many atoms would decay, a more perilous situation than hanging mid-air.